Section 6.7 is inverse relations and functions. Our goal is to verify that one function is the inverse of another. On page 477, we have if a relation pairs element A of its domain to element B of its range, the inverse relation pairs B with A. So if AB is an ordered pair of a relation, then BA is an ordered pair of its inverse. If both a relation and its inverse happen to be functions, they are inverse functions. The inverse of a function may or may not be a function. The diagram shows a relation R, a function, and its inverse, not a function. The range of the relation is the domain of the inverse. The domain of the relation is the range of the inverse. In the diagram, we have the relation R, domain 1.2, 1.4, 1.6, and 1.9. 1.2 goes to 1 in the range, 1.4 goes to 1, 1.6 goes to 2, and 1.9 goes to 2. Since every element of the domain only goes towards one element of the range, this is a function. When we look at the inverse, we switch the domain and range, so 1 and 2 become our domain, 1.2, 1.4, 1.6, and 1.9 become our range, and now we have 1 goes to 1.2, 1 goes to 1.4, 2 goes to 1.6, and 2 goes to 1.9. Since we have at least one element of the domain that goes to more than one element of the range, the inverse of R is not a function. Example 1 for part A says, what is the inverse of relation S? As we saw in the previous slide, to get the inverse of relation S, we just switch the x and y values. So if we have 0, -1 in our relation, the inverse will be -1, 0. 2, 0 in relation S will give us 0, 2 in the inverse. 3, 2 becomes 2, 3, and 4, 3 becomes 3, 4. Part B says, what are the graphs of S and its inverse? To graph S and its inverse, we can just use the points and plot them on their corresponding graph. For the first point, we have 0, -1, so we just go down to -1 on the y-axis. The corresponding point in the inverse would be -1, 0, so we go 1 to the left. For 2, 0, we go to the right 2, and the corresponding point in the inverse would be 0, 2, so we go up 2. In the relation, we have 3, 2, so we go to the right 3, up 2, and the corresponding point in the inverse would be 2, 3, so we would go to the right 2, up 3. Our last point in the relation is 4, 3, so we go to the right 4, up 3, and the corresponding point in the inverse is 3, 4, so we go to the right 3 and up 4. The following slide has all of the work written out for this problem, including a visual of how to graph the inverse based off the graph of the original relation. To graph the inverse, we use this red line, y equals x, and we just flip the point or reflect it over y equals x. Of course, since we already had a table of values, we could just plot the points from the table. Now I would like you to try number 1, find the inverse of each relation, graph the given relation and its inverse.